Last two. Here's number 12. So the first thing, they should not use L's and make them look like ones. So I curl my L's so you know they're L's. I noticed here, this has an outer exponent and so does this one. The first one doesn't, so I'm just gonna write it without the parentheses. So it just looks friendlier. Now this one becomes 2 to the second, m to the negative fifth to the second. This one becomes L to the first to the negative third, and M to the fourth to the negative third. All double exponents need to be multiplied. That's that, and that, and that. And 2 to the second is totally doable. 2 to the second is 4. So now we have 3 L to the negative second, M to the third, times 4 M to the negative 10th, times L to the negative third, M to the negative 12th. Now it's just a big giant multiplication problem. So I see the coefficients 3 and 4. They multiply to make 12. To multiply the L's, I have to add their exponents. So I have L to the negative second, L to the negative third, that's L to the negative 2 plus negative 3. To multiply the M's, I have to add their exponents. So I have M to the 3 plus negative 10 plus negative 12. So now I have 12L, negative 2 plus negative 3 is negative 5. And then M, 3 plus negative 10 is negative 7. Then plus negative 12 is negative 19. And then you say, oh, Ms. Colburn told me not to leave negative exponents in my final answer. So that means some items have to move. Let me tell you who's not going to move. The 12 is not going to move because the 12 does not have a negative exponent. The L and the M both have negative exponents, so they will move to the denominator, making your final answer 12 over L to the 5th, M to the 19th, and that is number 12. Last one.
You get batteries? Mom.
Yes, I bought batteries. I don't know where they are.
Fine.
Team, we have 6 x to the negative second, y to the 5th, over 2 x y to the second, z to the 6th, all raised to the 5th. Okay, so the first thing I noticed with this is that everything's being raised to the 5th power. I do not want to raise 6 to the 5th power because the number's just too big to deal with. So I'm going to start this question by reducing before I do anything else. So 6 over 2 is 3 over 1. So now we have 3 over 1, x to the negative second, y to the 5th, over x, y squared, z to the 6th,
Not until that's set.
all raised to the 5th.
Not until it's set.
Shh. Okay, now I'm going to distribute the power. So I'm going to end up with 3 to the 5th, x to the negative second to the 5th, y to the 5th to the 5th, over
Yo, we out here cartoon.
1 to the 5th, x to the 1st to the 5th, y to the 2nd to the 5th, z to the 6th to the 5th. 3 to the 5th means 3 times 3, which is 9, times 3 makes 27, times 3 makes 81, times 3 makes 243. So this is 243. If I multiply my double powers, I end up with x to the negative 10th, y to the 25th, over 1 to the 5th is 1 times 1, which is 1, times 1 is still 1, times 1 is still 1, times 1 is still 1. So this is 1, x to the 5th, y to the 10th, and z to the 30th. Okay, now what I do is I look to move any negative exponents. The only one that's going to move is x to the negative 10th. So in your numerator you have 243 y to the 25th over 1 x to the 5th, x to the 10th, who just moved down there, y to the 10th, and z to the 30th. And now you have to decide in the last step, adding and subtracting the powers. So for the x's, you'll add the powers. But for the y's, you'll subtract. So you still have 243 over 1. If I add the x powers down here, 5 plus 10 is 15. I have x to the 15th. When I go to deal with the y's, 25 minus 10 is 15, and the larger y is in the numerator, so y to the 15th will be in the numerator. And z to the 30th is just going to stay as it is. And that is your final answer, but if you want, you could take out the 1. And that is your even problems. Let me know if you still don't understand tomorrow, and we can video chat. Have a good day.